and welcome to the live broadcast for our 28th Electron launch, our first of two back-to-back missions for the United States National Reconnaissance Office. You're looking at a live view of our Electron rocket vertical on the pad for our WISE 1 Looks Ahead mission at Launch Complex 1 as we approach T-minus 17 minutes in the countdown to today's launch. My name is Felicity Powell, and I'm here with my colleague, Katie Gwozdecki, and we'll be with you throughout today's live broadcast from Rocket Lab's Mission Control Centre in Auckland, New Zealand.
That's right. Liftoff today is scheduled for 18:30 local time or 6:30 UTC. Launch operations are proceeding well as we approach T0. However, we're monitoring some strong upper-level winds as we move through the count. We'll keep an ear out for weather updates as we get closer to liftoff, and we can expect an update on this during the go-no-go poll soon. Flying on today's dedicated Electron launch is the National Reconnaissance Office, or the NRO. Headquartered in Chantilly, Virginia, the NRO develops and operates unique and innovative satellites to meet national security needs. Since 1961, NRO has pushed the envelope of U.S. space-based intelligence collection as it develops, acquires, launches, and operates the world's most capable intelligence satellites. Here's more about the National Reconnaissance Office.
For 60 years, we have been making the intelligence that keeps America safe possible. We are the leader in developing, building, launching, and operating our country's space reconnaissance systems. Our adversaries are moving fast, so we are moving faster to stay above all threats. We are going beyond, building resilience in everything we do, innovating faster to create the technology of the future with a world-class workforce alongside our partners and allies. Our future is built on more than half of a century of unrivaled success in space operations. The National Reconnaissance Office, above and beyond.
We're honored to be partnering with the NRO and excited to be launching for them once again. Today's NROL-162 payload will be used by the NRO to help provide national decision makers and intelligence analysts with timely information that supports their interests and humanitarian efforts across the world. We have flown missions to space for the NRO twice before. The first was the Birds of a Feather mission, launched in January 2020, our 11th Electron launch from Launch Complex 1. That mission included a dedicated ride on Electron for the NROL-151 payload and also had some very early rocket reusability testing, where we successfully completed a guided re-entry of Electron through Earth's atmosphere after launch. It's amazing to think that since that mission launched just over 2 years ago, we've progressed our efforts to make Electron the world's first reusable small rocket, to the point that we are now snatching Electron out of the sky with our own rocket-catching helicopter.
Shortly after the Birds of a Feather mission, we launched 3 NRO payloads on our second mission under the NRO's Rapid Acquisition of a Small Rocket contract, or RASER contract, collectively called RASER 2. On board the Don't Stop Me Now mission were 3 satellites, designed, built, and operated by the NRO, but in this instance they flew on a commercial rideshare mission, alongside small sats by NASA and the University of New South Wales Canberra Space, together with the Australian Air Force. Today's mission will be the 3rd NRO mission to fly on Electron under the RASER contract, which supports the NRO to launch small satellites commercially through a streamlined approach.
For every launch to space, we come up with a name that represents that particular launch and our customer's mission, and a unique mission patch to match. For NROL-162, the name Wise One Looks Ahead is a translation of the NRO's Latin catchphrase for this mission, Sapiens Qui Prospicit. For the NRO, this represents their work with present and future partners in space. In particular, it's a shout-out to their partnership with the Australian Department of Defence, as the NRO commits to enhancing its relationships with allies.
And while the bird on the patch might seem familiar to our US viewers, it is in fact an Australian wedge-tailed eagle, used on this patch to further symbolize the 2 organizations' partnership in space. The NRO has also come up with its own patch for this mission, one which instead features an Australian frilled neck lizard to represent the small and agile nature of the payload being launched on today's mission.
A quick check-in on the countdown clock and we can see we're at T-minus 12 minutes to liftoff. Soon our launch director Joseph Carpico will check in with each mission operator for a quick green or red on whether to proceed with the remainder of the count. This is called the Go, No-Go poll for launch, and it will be coming up shortly. Let's listen in.
All operators, this is the LD on mission, proceeding with the go, no-go sequence. Stage.
Stage is go.
Avionics.
Avionics is go.
VCON.
VCON is go.
T1.
T1 is go.
GC.
GC is go for launch.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
GNC.
GNC is go.
MM.
MM is go.
SVMD.
MD is go.
LD sub.
LD sup is go.
That completes the go, no-go sequence. We are T-minus 11 minutes, 16 seconds and counting. We are go for terminal count at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
And with that, our launch director has confirmed that we are go for today's launch. Liftoff from Pad A has been set today for 18:30 local time or 06:30 UTC. For our Eastern Time Zone viewers, that's 02:30 in the morning. And in Pacific Time, liftoff is targeted for 23:30.
Agility and quick access to space are increasingly important to the way the world responds to conflicts and crises. Using the vantage of satellites above us, data and imagery from the right place at the right time can provide decision makers with insights into ship and plane movements, weather patterns, and economic activity. During humanitarian crises, satellite data can reveal troop movements and refugee streams that help governments, first responders, and aid organizations focus on where they're needed the most. The faster satellites can be placed in space, the more capable space infrastructure will be. But to do that, modern nations need responsive rockets, responsive launch pads, and responsive satellites. And at Rocket Lab, we have all three. Responsive satellites are ones which are small, simple, and fast to build, and can do a number of different things to suit the mission, which is exactly what our Photon satellite bus was designed to deliver. Based off Electron's kick stage, this small satellite bus is capable of big science.
Speaking of Electron, our rocket is streamlined and fast to build compared to much larger or traditional rockets. With 147 satellites delivered to orbit, Electron is ideal for responsive launch. And once we turn Electron into a reusable rocket, our launch cadence and responsiveness will only increase. So with responsive satellites needing responsive rockets, and the third piece of the puzzle is a responsive launch range to fly them from. Public ranges have to cater to multiple launches, all vying for the launch pad and a free slot to fly. But with a private range like Launch Complex 1, our only priority is Electron. One orbital launch pad wasn't enough. Now we have two, and to go along with them is our own private range control, rocket integration hangar, payload clean rooms, and 120 opportunities to fly every year.
Just last week, we wrapped up our first ever mission to the moon. And now here we are, back at the pad, ready to watch Electron lift off at Launch Complex 1 for the second time in 15 days. The Capstone mission is the first step in support of NASA's Artemis program to return humans to the moon. And our role of this mission not only included a dedicated launch on Electron, but also featured in-space assistance with the debut of our lunar Photon spacecraft to help Capstone reach the moon.
The first phase of the mission on Electron saw Capstone leave the launch pad at Launch Complex 1 on June 28th during a flawless nighttime launch. Our rocket made it through the usual launch milestones before Capstone was dropped off to a very low Earth orbit of just 165 kilometers. In Phase 2, that's when our lunar Photon spacecraft came alive and took over the mission. Over the next 6 days, lunar Photon slowly and steadily raised Capstone higher above Earth in increasingly elliptical passes using our own Hypercurie engine, before finally we shot Photon and Capstone free of Earth's gravitational pull and on a path to the moon with a super-powered engine burn. Capstone was then detached from Photon, marking the successful end of Rocket Lab's involvement in the mission, as management of the CubeSat's solo journey to the moon was handed over to NASA and Advanced Space.
The Capstone mission marked the beginning of humanity's return to the moon through NASA's Artemis program, and we're incredibly proud to have played a key role in that. Our team dedicated 2 years of their lives to this mission, working on the design of our lunar photon spacecraft, the development of our first deep space engine Hypercurie, setting the mission trajectories to deliver Capstone on its lunar path, and so much more. Capstone was by far our most complex mission to date as we pushed Electron and Photon to their limits. But now, having proven what we can do with our groundbreaking technology and small satellite missions beyond Earth, we're already looking forward to more interplanetary missions, including our upcoming journeys to Venus and Mars as early as next year.
Now, back to the mission at hand. Preparation for today's launch began several hours ago as the vehicle was rolled out from the hangar to its launch position at the end of the runway. Here, the strongback lifts Electron to its vertical position on the pad, a process that only takes a few minutes. We begin LOX fill, fueling Electron with super chilled liquid oxygen at around 2 hours prior to scheduled liftoff. We do this as late as possible to keep the LOX as cold as possible.
In the hour before T0, mission control operators are continually checking the vehicle systems are healthy and that the conditions are favorable for liftoff. With 18 minutes left on the clock, the launch director runs the go-no-go poll with launch operators to confirm Electron is ready for flight. At T-minus 2 minutes, Electron transitions to autonomous flight control and takes over the launch countdown. The famous countdown is conducted by the launch director from T-minus 10 seconds, and with 3 seconds to 0, Electron's 9 Rutherford engines ignite and lift the vehicle off the pad.
Liftoff itself is a milestone, but there are many other checkpoints in Electron's journey between preparations and mission success. First, Electron must pass through max Q, maximum aerodynamic pressure, where the point where the forces acting on the rocket in flight are at their maximum strength. Mission control will confirm when Electron has passed max Q. The next checkpoint is main engine cutoff, when the 9 Rutherford engines on Electron's first stage power down to decelerate the vehicle a few moments before the first stage separates from the vehicle. From here, the single space-optimized Rutherford engine on the second stage fires up to push the second stage and kick stage with payload attached the rest of the way to pass the Kármán line into space. At this point, the payload fairing on Electron's nose will separate and fall away, no longer needed to protect the satellite from Earth's atmosphere.
Once Electron has reached an altitude close to where the satellite needs to be deployed, the second stage of the vehicle separates from the third stage, called the kick stage. This kick stage is propelled by a much smaller engine called Curie, which can then propel the satellite to its precise destination, sometimes within just meters of its intended orbital location. As soon as the kick stage has deposited the satellite to where it needs to be, we can declare the mission a success and congratulate our customers on finding their new place in space, while Rocket Lab adds another successful mission to our heritage.
And so, with just 3 minutes left before liftoff, let's switch to mission control to hear the final countdown before launch.
This is the LD on mission. From now on, there should be no red flags on your critical LCCs. Beacon LD on mission.
LD Vicon.
Yes, sir. Please confirm all expected flight computer ASGOs are green.
Confirmed, all ASGOs are green.
And Vicon lock auto sequence and confirm.
Confirmed, auto sequence is locked.
This is the LD on mission. We are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
LDGC on mission.
Go ahead, GC.
ECS disabled, pad auto sequence is armed, pad ready for launch.
Copy, GC.
Vehicle is on internal power. AFTS is green and enabled for flight.
Lock load complete. Lock system in recirc. All helium anti-gathering disabled.
Stage 1, Stage 2, press for flight.
High flow engine purge enabled. Water deluge activated.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we have liftoff.
Stage 1 propulsion is nominal.
High voltage battery discharge, nominal.
Our 28th Electron launch vehicle has successfully lifted off the pad and is on its way to space. Before it gets there, it has a number of critical milestones to pass through, the first of which is called Max Q. Max Q is the first test in Electron's journey, where it experiences maximum aerodynamic pressure, or where the forces on the rocket are at their peak.
Past Max Q.
Nice.
There's the call. Mission Control has reported Electron has successfully passed through Max Q, its first milestone after lifting off from the east coast of New Zealand. The 9 Rutherford engines on Electron's first stage are performing well, and we're ready for the next series of milestones in the launch process.
Up next is main engine cutoff, known as MECO, which immediately precedes Stage 1 separation. MECO allows the vehicle to decelerate slightly before the first stage separates from the second stage. As the first stage falls back to Earth, the single space-optimized Rutherford engine on the second stage ignites to take the vehicle, with payload, the rest of the way into space. You'll see both events on screen, and we should hear Mission Control confirm from vehicle telemetry.
Stage 1 propulsion holding nominal. Standby for MECO in around 30 seconds.
High voltage battery discharge, nominal. Entered burnout detect mode.
MECO confirm.
Stage separation successful.
And stage mission.
You can see on your screen that Electron's first and second stages have successfully separated. The single space-optimized Rutherford engine on Electron's second stage is glowing red as the nozzle radiates heat from the exhaust. Because the vehicle has now cleared the majority of Earth's atmosphere, we can get rid of the payload fairing to shed some extra weight. We should see that on our screens shortly.
Fairing jettison succeeded.
Stage 2 propulsion is
And there it
nominal.
is. You can hear the payload fairing tumbling away on your screens now. The NRO payload is now exposed to space in preparation for payload deployment later in the mission.
This fairing will burn up as it re-enters the atmosphere, while the second stage continues on. If you're just joining us, we've had a successful start to Electron's 28th flight. The vehicle cleared Pad A at Launch Complex 1 at 0630 UTC and has successfully passed through its initial key milestones on its way to payload deployment. The second stage is now ignited and carrying the kick stage with the payload attached the rest of the way into space. At about 10 minutes into the mission, the kick stage will separate and its Curie engine will precisely deliver the payload to its intended orbit.
The shape of an orbit is important. In fact, the entire Capstone mission we launched last month is to test the efficiency of the near rectilinear halo orbit, or NRHO, around the Moon. In most Electron missions, our second stage delivers the payload to an elliptical orbit. We then use the Curie engine on the kick stage to circularize that orbit, basically make it circular, to deliver the payload to its new home in space. Quick update, Mission Control is reporting the vehicle is healthy and making good progress onward to deliver its NRO payload.
If you were ever curious, when Electron takes off, it weighs 13 tons, but 90% of that is actually fuel. Electron is so efficient that by the time we reach MECO, it only weighs 1.25 tons. To optimize our weight, we also use a carbon composite shell that in some places is less than 2 millimeters thick. That's thinner than your windows at home. Carbon fiber materials are strong enough to manage the environmental stress from launch while being lighter weight than traditional materials, so we can bring even more payload mass to space for the same fuel.
Thank you.
200 seconds to go.
Electron is one of a kind for many reasons, and one is that its engines, all 11 of them, use electric pumps to feed the propellant. Batteries are one of the few items that maintain their weight as they are drained, so once we use them up, we need to get rid of them to keep our flight easy and efficient. This process is called the battery hot swap and is about to take place as the batteries we started with at liftoff are now depleted. Keep an eye on your screen and that shiny object to the right, as you can often see them falling from the vehicle. But we'll hear the battery hot swap call from Mission Control as well.
Hot swap successful.
Battery jettison confirmed.
There you have it. It happens quick, so hopefully you caught a glimpse as those batteries were ejected from the vehicle. Electron continues nominally through its second stage burn, with kick stage separation coming up in the next few minutes.
FDS has saved.
The vehicle is continuing well onto orbit and we're making good progress in our journey to payload deployment. Before, you may have heard Katie talking about how much of the mass of a space rocket is propellant or fuel. But what happens as we use it up? Electron uses most of that fuel in just 8 minutes, which creates a lot of empty space inside the rocket. We actually use helium gas to maintain equilibrium in pressure between the inside and outside of the rocket.
High voltage battery discharge holding nominal.
The views on screen show the glowing red nozzle of our Stage 2 engine. The Rutherford engine on our first stage inspired this second stage, but they operate in fundamentally different environments. Rutherford nozzles are designed with a focus on corrosion resistance and environmental robustness, as it must survive the super high temperatures and pressures during launch. Our second stage engines are designed for space propulsion, so we instead focus on making sure it can cool itself off as it gets extremely hot without convection in the vacuum of space. You can see this happening as it glows red on camera. Both of these engines are 3D printed in our Rocket Lab factory in California, allowing our engineers to easily make small tweaks to make our engines more and more efficient after each flight.
Entered burnout detect mode.
Stage 2 propulsion.
Our next big milestone for Electron is second engine cutoff, or SECO. Just like MECO, or main engine cutoff, the engine on this stage will shut off ahead of the final separation of the second stage from the last or third stage of the vehicle, the kick stage. At this point, the small but mighty Curie engine on the kick stage will carry the payload to its exact destination in space. For this mission, we'll wave goodbye to the kick stage and to you after SECO and second stage separation.
SECO confirm.
Perfect transfer orbit.
Sweet.
Nominal transfer orbit achieved. Stage 3 separation confirmed.
We've received confirmation from Mission Control that Electron's second stage engine has shut down and the kick stage has successfully separated, now en route to deliver the payload to its destination in orbit. Over the next hour or so, the kick stage will make its way to the correct location in low Earth orbit ahead of payload deployment. Thank you to the NRO for choosing to fly on Electron, and thank you at home for joining us for our 28th Electron launch. Having added our first successful interplanetary mission to our manifest after Capstone was successfully inserted into its ballistic lunar trajectory last week, we are actively recruiting the next generation of space talent as we grow and stretch our reach beyond stars to further fields. In particular, we're hiring mission operators for our Mission Control Center. If you want to be at the controls of some of the most exciting new ventures in commercial space exploration as humanity returns to the Moon, Mars, and beyond, apply today by visiting rocketlabusa.com.
And if you're still in school or further education, we have plenty of opportunities for you to get involved with the space industry as you plot your path to the stars. For students, parents, and educators, please visit rocketlabusa.com/education for information on how you can stay inspired, informed, and involved in Rocket Lab's mission to make space accessible for all. Of course, you can always stay in contact with us by following us on social media to stay up to date with everything we do at Rocket Lab. It's been great to have you share these moments with us. I'm Felicity Powell.
And I'm Katie Gwozdecki. This is Rocket Lab Mission Control, signing off.